Hello, today I'm going to talk about why DataOps. Before we dive into the subject, it's important to understand the evolution of how analytics teams usually end up growing. So to begin with, usually you have one or a very few sources where we are ingesting data from when our analytics teams start at the beginning. And at this point, it's more of a POC kind of stage. And it's the typical process they follow where the data gets ingested into some sort of data lakes. They do some curation and build a very basic model, can be a data mart, and then feed that into analytics for building dashboard, BI dashboards or analytics reports. And that's usually where this starts. And at this point, the focus primarily is on proving that analytics is helping the business, and there isn't, in some cases there may or may not be a lot of ETLs happening. Yes, sure, basic curation is happening, some cleansing is there. In the modeling phase might be some derived columns, facts dimension tables, but usually to begin with it's not as complicated. And with a very basic structure, even things work fine and teams are able to deliver relatively quickly because they don't have a lot of logic written in those ETL pipelines. Now, as success grows of the analytics function, a lot of more use cases come in, and that's where we end up having a lot more data sources, APIs, databases, might be FTP files, so on and so forth, from internal inside the organization and from outside the organization as well. And then the also your consumers begin to increase, right? So your business users, primarily in the past it may be from one operational area, and then as you add more business users from different operational areas, their understanding of different data attributes might be different. So for example, end of financial year, or when they calculate profit and loss, exact time for one department might be different from the other, might be slightly different. Similarly, the definition of customers, these are some very basic data attributes which often departments don't agree on, and that's where the the difference in understanding starts to build. So that is an additional big challenge which teams then end up having. External users, you might in some cases might have external vendors also trying to ingest that data, and in some cases prior and the early stages you might have just batch processes because we're just generating dashboards which are updated once a day, and that's fine to begin with. But then when business users start to use these analytics reports more in their operational day-to-day usage, then they start to add more near real-time requirements, which means that they need a more frequent update, and that puts a strain on the whole analytics pipeline, and your NFRs fundamentally change across your pipeline. And then it does happen sometimes where operational systems also get involved, which sometimes might need real-time data, and now that is even more stringent NFRs which they have to comply with. And as you see, a lot of different teams might have different performance requirements. The stage at which they read data from your data pipeline would also be different. So for example, operational systems might start reading data from the data model, domain model directly, because they don't need a lot of curation. They just need different data from different sources joined and just shared. Data science use cases for generating test data for ML models might also just come right off of the domain model stage of your pipeline. However, data marts would require all of that coming from your data warehouse. Now all of that becomes, you have to manage which logic needs to be written on the domain model and which is going to stay in the data warehouse for data marts, because as you see more and more systems start to ask for same business workflows, you might want to abstract that out into the domain model instead of the data mart, so on and so forth. And that's where the complexity starts to build and your ETL pipelines start to become more complex. Now, given all of this, the initial design which you might have wasn't supposed to meet all the requirements that you have now that we talked about. And that is where teams then struggle to deliver quickly. They take more time because changing one aspect, you might say, okay, I need a new feature in this job, which is somewhere in the domain model, let's say. Now, for a business user, they might say it's just a small change, but the impact of that change is across a lot of different systems who are using that in the, let's say, data mart. Even from the domain model, different other operational systems are using that. So there's a lot of knock-on effect which happens when you change the ETL in a job, and those are the things that then which slows teams progress down. Also, data quality becomes a problem because now we have competing definitions of what a data attribute might mean. Different business users would have a different definition, and also because of the complexity of different sources using data at different stages, that also adds to the problem. So, and of course, you have a lot more sources coming in, and making that data homogeneous is of course a big challenge, which adds again problems to the data quality. So all of this, in short, is scaling problems, and that is where DataOps now comes in. Once you've reached this stage and you have a lot of complexity in your landscape, now just, of course, you have to relook your architecture, but then you need a lot of enablers in place. And that's so DataOps isn't necessarily something fundamentally new or different. It's pieces or lessons learned taken from DevOps, agile practices, so on and so forth, and just made them a bit more understandable for the big data domain. So back to our diagram. Now you might want to add a lot of enablers, and while this is a relatively longer list, and I'll link the article I have on this in the comments in the description below, but so the main ones for me, important ones, are first, automated deployment. What that means is, me as a developer, when I've changed an ETL flow, I just need, as soon as I raise a pull request and gets approved, which the code review happens, from that moment till that being deployed, that ETL job being deployed in dev staging or production should be automated without having the need of any manual intervention. Sometimes teams, this is a complicated process for teams to deploy an ETL job. So if you have, let's say, a Spark project, changing something and deploying it sometimes has a lot of steps in there, and it takes a lot of time to do that, and especially in development and testing, especially with data pipelines, the test really needs to a lot of tests usually teams do after they've deployed that ETL pipeline, and that's when you know there's a problem. So you might have to do that deploy part multiple times quite frequently, and if that takes time, it is taking away from, it's just a mundane activity which the engineers have to spend time on. So and when I say deploy, so that we're talking about a CI pipeline, and the CI pipeline should involve the important stages there would be static code analysis, unit tests, and component tests, which leads to the next topic of data quality. A lot of teams end up doing data quality checks or test automation on the whole data pipeline. So they'll try to put some data in the data lake and run it through till the data warehouse and try and verify the results over there. Now, while that isn't required, but that is a very big scope of work which we're trying to check in one shot, which isn't necessarily the best thing to do. It's really advisable to have small independent atomic tests which should run for each ETL job separately. So again, back to my CI pipeline, when I raise a pull request for a change in one ETL job, unit tests and component tests for that ETL job run and deploy. And that way I make sure that that individual ETL job is done, is all the positive and negative scenarios are covered there. That way, when you reach to the end of when all of your individual ETL jobs are tested thoroughly with positive and negative scenarios, then validating the end-to-end integration test becomes a lot easier. So that's about data quality. Monitoring and observability. Now, if you've checked the aspect of data quality in dev and stage, that does not mean that you can be 100% sure or even 70-80% sure that your pipeline is going to be fine, because a very big component of data pipeline success is the source data, which we've learned from practice is never going to be perfect. It's a fallacy to expect that even. So we always know that there are going to be we will always ingest data which perhaps shouldn't be there in the first place. It should be fixed at source. So monitoring and observability becomes a really important part here, because to make sure the health or the data quality of my data pipeline is in a good place, I need to have observability into what's the quality in production in real time. And that can happen by having data quality checks across your data pipeline at all different stages in your data lake, when it's ingesting from source, after you've done your domain modeling, during the domain modeling process, on your data warehouse, in your data marts, and some business logic API checks on your analytics. So at least this much would give you a fairly decent picture of what is the health of your data pipeline. Now, for all of this to happen, there are a lot of other enablers which are required. Source control management, of course, no brainer. Environment creation and management, we talked about that for automated deployment, very big piece. Depending on your tech stack, this is going to be perhaps one of the most complicated ones. Metadata management, from data governance, this is, I think, the most important part, especially when it comes to related to DataOps, so to speak. And understanding and of what those data attributes mean is very important, and that can be ensured by metadata management, which is extremely crucial. Then you have role-based access controls, RBACs, and security, PII information, GDPR compliance, so on and so forth. So those are your very basic DataOps enablers. The list is definitely longer than these few points, but I've just mentioned the very important ones. And now you've noticed, for all of this to happen, we need very strong collaboration between teams, and that's where the agile ways of working come in. Lots of collaboration required and a culture of openness and sharing, because especially with analytics projects, a lot of delivering one BI solution or analytics solution depends on a lot of series of steps happening in sequence. Anything goes wrong, it creates a problem down the line. So, and for all of these enablers to be in place, there needs to be a lot of collaboration between teams, which is why it's extremely crucial that the agile ways of working are adopted in teams, and there is a culture of openness and psychological safety. Thank you for watching. See you next time.